determine the interval of convergence and radius of convergence of this power series. The reason I picked this problem is because this series is raised to the n root, right? So we have x minus 2 raised to the n. The bottom we have n raised to the n. So overall, we have the entire series raised to the nth power. So under what circumstances do you use the root test? Do you see that the root test? So you use the nth root test when the entire series is raised to the nth power. So here is how we do the root test. So we have limit as n approaches to infinity. So we take the nth root of the absolute value of an. And then that is a limit as n approaches to infinity. That is the nth root of the absolute value of x minus 2 divided by n, and then you raise to the n, right? So do you still remember this? So let's say we have x to the third power. If you take the cube root of that, that is equals to x to the third, and then raise to 1/3 power, that is equals to x, right? So in here, the nth root and the nth power, they got cancelled. So we have limit as n approaches to infinity. So n is 1 or above. So n is always positive. We don't need the absolute value for that anymore. But the x is not. So the x is x minus 2 in parentheses. And then what is that equal to? That's the reason I picked this problem. When n approaches to infinity, you have x divided by 2 over infinity. So x divided by 2 minus 2 divided by infinity, that is equals to 0. What do we do when we find the interval of convergence? So do you take a look at the series? We have the whole thing raised to the nth power, right? So that is just like the geometric series where you have a common ratio raised to the nth power. In order for the geometric series to be convergent, the absolute value of the common ratio must be less than 1. So as a result, the result of the limit must be less than 1 because we treat the entire base as a common ratio. So when that is less than 1, in fact 0 is less than 1, so that means we don't have any more x to solve. So in the previous problem, we always have the absolute value of x is less than 1, and then you get an compound inequality, and then you test the each n, right? And then this one, there is nothing to test, so you have 0 less than 1. What does that mean? That means the series converges for all x by the root test. And then we draw a conclusion. So this line represents x. So we have x, then there is no interval. The 0 is right in the middle. Then we say that the x is the series is converges for any value of x. So the interval of convergence is from negative infinity to positive infinity, or you can say x can be any real number. So x is an element of all real numbers. So x can be anything you want. The series is always convergent. So that is the end of this video. So in the next video, I will solve another power series. All right, I see you all in the next video. As always, if you think my instruction is helpful, I picked the best problem ever, let me know in the comment section below. A thank you would be nice. Like the video, share the video for me, subscribe to my channel if you haven't done so. I see you all in the next lesson. Signing out.